face my board. Okay, so let's start with complexometric titrations. Complexometric titrations. Now the definition. What are complexometric titrations? If you see your textbook, they have given complexometric titration is the formation of soluble undissociated complex when you add titrant to the. So it is a titration in which a soluble, very important, soluble, undissociated complex is formed during addition of titrant to your metal ion solution. Okay, so Bure and the titrant most commonly used is a complexing agent. And the most common complexing agent used is EDTA. So what I have written over here is in the burette, I will have a complexing agent. In my conical flask, I will take a metal ion solution to be estimated. So when I titrate this type of titration is called as complexometric titrations. In our last class, we have studied what are acid-base titrations. What are acid-base titration? Is titration of an acid against a base और टाइट्रेशन ऑफ अ बेस अगेंस्ट एसिड. आपको अगर एसिड टाइट्रेट डिटरमाइन करना है तो बेस के साथ टाइट्रेट करो. बेस इफ यू वांट टू एस्टिमेट यू कैन टाइट्रेट इट अगेंस्ट एसिड. But if my teacher gives me metal ion solution, metal ion मतलब copper solution, if I give you, how will you estimate? You will not titrate it against an acid or a base. You will titrate it against a complexing agent. So when you titrate a metal ion against complexing agent, the titration is called as complexometric titration. I hope this is clear now. And what happens, complexometric titration, when you do, you will find that it is a soluble. Complex मतलब ऐसा precipitate वगैरह नहीं होता है, soluble ही होता है, clear solution, colored हो सकता है, colorless, but the solution is soluble, complex is soluble, it is not dissociated when you add a complexing agent to the metal ion. Please remember the concept. You have studied 4 types of titration: acid-base titration, redox titrations, complexometric titrations, and you all also had studied precipitation titrations. In last class, we have studied acid-base. Now we will be studying complexometric titration, right? So now let's see what is EDTA. EDTA is most commonly used complexing agent. What is EDTA? Full form is ethylene diamine tetra acetic acid. I hope my voice is clear. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. Huh? So ethylene diamine, full form of EDTA is ethylene diamine tetraacetic acid. So when you write the formula, you will write it as ethylene बराबर है डायअमाइन. सो दो इधर आएगा अमाइन ग्रुप मतलब 3 बॉन्ड 1 लोन पेयर ऑफ इलेक्ट्रॉन. करेक्ट. So this is the ethylene group, this is the diamine group, and then you have tetraacetic acid group. Acetic acid is what? CH3COH. When you attach over here, you get this group acetate. CH2COOH. CH2COOH. So this is a formula of ethylene diamine tetraacetic acid. Right. Now this is a complexing agent. ये क्या है? Complexing agent. Complexing agent. And this is usually filled in the burette. Now what happens is this ethylene diamine will coordinate to the metal atoms through six sites. Sites मतलब through two nitrogen atoms. Then you have four. See, this is my, this will go. So you have four oxygen atoms for coordination. Okay, this oxygen, and this oxygen. So you have four oxygen atoms for coordination. So total you have ethylene diamine tetraacetic acid will coordinate to the metal ion through six atoms, six of its sides, and therefore EDTA is also called as hexadentate ligand. Dentate ligand. I repeat, EDTA का formula is this. It will coordinate to the metal ion through these two nitrogen atoms and four oxygen atoms. This, and this. Right? So if I ask, see, there are many objective questions only on this. It will be there. Now listen. If I ask you fill in the blanks, EDTA coordinates two metal atoms through dash nitrogen atoms. If I ask this, the answer will be two of its nitrogen atoms. If I ask, please listen. If you are having a textbook, please mark or write it in your notebook. EDTA will coordinate to the metal ion through four oxygen atoms. Please, whenever you solve objective question, you read the question, whether they have asked nitrogen. If they have asked nitrogen, it will be two, oxygen होगा तो four, or I may ask, EDTA will coordinate through dash atoms. How many atoms? Six atoms. So year only you should know one of the question may be asked. This is more frequently asked. Therefore, EDTA is also called as hexadentate ligand. Dentate ligand. Okay. What is a ligand? You have studied in the previous class. Okay, so we have seen here what is complexometric titration. Immediately you should answer. It is a titration in which a soluble, undissociated complex is formed when you add a complexing agent to the metal ion solution. Complexing agent used is EDTA, full form ethylene diamine tetraacetic acid. Formula, this is the ethylene group, diamine, and you have tetraacetic acid. Please write it in your notebook. Whatever I am telling you, it's very, very important. Ethylene diamine will coordinate to metal ion through two nitrogen atoms. And how many oxygen atoms? Four oxygen atoms. So total how many atoms are there for coordination? Six atoms. And hence EDTA is a hexadentate ligand. I hope this much part is clear. Now we will proceed. The fun is ahead. You can see the beauty of this EDTA as a reagent. Now see what happens is this EDTA formula every time to write in the reaction is very big. So in short, this is written as H4Y. ये 4 dissociable hydrogen ions है ना, ये H4. So this is H4Y. I hope this is clear. What is H4Y? EDTA, you can write it as H4Y. Hmm? Now next, this EDTA, if you see, it is sparingly soluble in water, sparingly soluble in water. And see, and therefore we cannot use this for titrations. Then you will say, madam, you are saying it cannot be used, and here you are writing it is used as a complex reagent. Listen, listen. EDTA is sparingly soluble in water. It is not, therefore we cannot use it for titration. For titration, solutions should always be clear. So instead of this, we are going to use a disodium salt of EDTA. I always tell you, whenever in research you get stuck up somewhere because the compound is not soluble in the solvent, unless it goes in the soluble form, it will not react. Yaad rakho, you will definitely remember my word. Convert it into sodium or potassium form. So here we will be using the disodium salt of EDTA, NO2H2Y. And this disodium salt of EDTA is soluble in water. So when you do practical, you see the container name. It is disodium salt of EDTA. And this also can be written as Na, it can be written as H2Y2 minus. इन शॉर्ट इतना बड़ा नहीं लिख सकते हम लोग. सो डाई सोडियम मतलब क्या, इधर माइनस होगा, इधर सोडियम पॉजिटिव होगा, इधर नाइट माइनस होगा. दिस इज डाई सोडियम सॉल्ट ऑफ ईडीटी, राइट. सो I again repeat, H4Y is EDTA full. It is not soluble in water. So I will use the disodium salt of EDTA. This also can be written as H2Y2 minus. I hope this everyone understood what I have done over here. Now this is the basic. Now what reaction? Viva question. Write the reaction of metal ions with EDTA. अभी ये EDTA मैंने ब्यूरेट में भरा है, right? What I am going to fill in the burette is this H2Y2 minus. This I will react with the metal ion. So I have to write the reaction. So the reaction will go as follows. Metal ion. In that I am going to add H2Y2 minus. What is H2Y2 minus? It is a disodium salt of EDTA. Short form. Every time I cannot write this big structure, metal ion, not possible. Okay. So I will write this, and equilibrium will be reached, and MyN minus 4 plus 2H plus. Please do this reaction. Metal ion will react with EDTA to form MyN minus 4H plus. So suppose I am having a univalent metal ion M plus 1. My reaction will be My N minus 4. N is what? 1 minus 4. So 3 minus plus 2H plus. If I take a divalent metal ion, divalent में भी क्या आएगा? H2Y2 minus My 2 minus plus 2H plus. If I take a trivalent like aluminium, उसको अगर मैंने टाइट्रेट किया तो मेरा रिएक्शन कितना आएगा? -1 प्लस 2H प्लस. अगर मैंने हेक्सावेलेंट लिया, टेट्रावेलेंट लिया, and if I titrate against EDTA, what I am going to get? My plus 2H plus. My 0 मतलब क्या है? न्यूट्रल. Okay. So now listen, this is a reaction, general reaction everyone should know. Metal ions will react with sodium salt of EDTA to form MyN minus 4 plus 2H plus. कभी कभी बुक्स में N minus 4 के बाद प्लस होता है. ओके. Once you know this, you can write reaction with any univalent metal ion, divalent, trivalent, and tetravalent. Why I have written so much? Please, now what I'm going to say is very, 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 very important. If you see, even with divalent, trivalent, hexavalent, EDTA reacts in the ratio of 1:1. See, NaOH और सल्फ्यूरिक में लिखा तो कैसे रिएक्शन है? 2NaOH plus 1 sulfuric. HCl with NaOH 1:1. So it varies, but the beauty of EDTA titration is that metal ions, all metal ions will react with EDTA in the ratio of 1:1, and hence the calculation part becomes easy. This everyone will not understand. Only 1% of the full class will understand what is 1:1 का importance. इसका importance सिर्फ 2 या 3 लोगों को समझेगा. I repeat, EDTA will react with any metal ion in the ratio of 1:1. And here the advantage will be calculation part becomes easy. Okay. So this is the basic introduction of EDTA titrations. I'll revise the full part. First, we discussed what is complexometric titration, in which a soluble, please the word soluble should be there, undissociated complex is formed during the addition of titrant, matlab complexing agent, to the metal ion solution. In the burette, we will take a complexing agent. Most commonly used complexing agent is EDTA. What is the full form? Ethylene diamine tetraacetic acid. The formula of ethylene diamine tetraacetic acid I have shown over here. It has got, it coordinates to the metal ion through 2 nitrogen atoms, 4 oxygen atoms. So total how many atoms are there for coordination? 6 atoms. And therefore EDTA ligand is also called as hexadentate ligand. Then let's come to about EDTA. Whole structure every time to write is not feasible. So you write it as H4Y. But this is sparingly soluble in water. पूरा soluble ही नहीं है. तो हम लोग क्या करेंगे? Disodium salt of EDTA use करेंगे. Sodium salt use किया तो compound will definitely be soluble. So what happens? Your H4Y is EDTA, sodium salt, I can write it as H2Y2 minus. So in practical, if I ask you to write the reaction of metal with EDTA, here is the metal plus EDTA giving out this. Then I have shown you that EDTA will react with any metal ion, whether it is the di, tri, tetramuni, in the ratio of 1:1. Even MSc students don't understand the significance of 1:1. One more important point I forgot to tell you is, see, in EDTA titrations, ions are liberated. Since ions are liberated, these titrations are dependent titrations, are dependent on pH of the solution. Means they are sensitive. We have seen in talcum powder for estimation of magnesium, pH was adjusted to 10 by adding a buffer. because in all this achions are liberated. So this is the basic concept. If you understand this, you will like the topic. You should know, अगर मैडम ने मुझे मेटल आयन सोल्यूशन दिया है, I should titrate it against acid, base or a complexing agent. Don't go to acid, don't go to base. Metal ions you will titrate against a complexing agent. Use logic. किधर भी लेके HCl या NaOH के साथ टाइट्रेट नहीं करना है. मेटल आयंस होगा तो कॉम्प्लेक्सिंग एजेंट ही ब्यूरेट में भरना है. ओके, so this was the introduction part. Buffers have to be added during EDTA titrations because achions are liberated. They react in the ratio of 1:1. So the question, 1 minute, I'll take my black marker. So the objective question most frequently used. This one, how many nitrogen atomic coordinates, how many oxygen atoms, total how many atoms, it will react with any metal and see what we do every time we need to take new questions. So in one paper I will ask it reacts in 1:1. Second I will ask Zn plus 2 will react with EDTA in the ratio of dash. I will write 1:1, 1:2, 2:1, or I may write any ratio. What happens, students get 2 plus देके they are confused, 1:2 है कि 2:1 है. Then they will ask query. No, it will react with 1:1. Next year paper. Aluminium will react with EDTA in the ratio of dash. बस इतना पढ़ के इतना सिखा के भी option 1:3, 3:1, any. They will be struggling with this. Simple, it reacts only in the ratio. So there are so many questions which will be asked from only this. Next, EDTA titrations are sensitive to pH. True or false? My God, what is there so much to think about it? First, finish. Okay, then I may ask, EDTA is a hexadentate ligand. This is one of the questions that can be asked. Then for titration, complexometric titration, dash is filled in the burette. Complexing agent, acid, base, cheminophore. What is the correct answer? Complexing agent. This will fetch you 3 marks. If you understand this, definitely 3 objective questions will be asked because this is the basic. Okay. So this is complexometric titration. Now we will start with types of complexometric titration. Okay. I hope this part is very, very, very clear to you all. If you have any questions, you can put it in the chat box. Okay. So Abhi, very, very interesting. Students write very nice answer, university students. Okay. So types of EDTA titration, EDTA titrations. Paila type, first type. First type is the direct titration. So what happens in direct titration? What we do? In the direct titration, the solution containing metal ions is buffered at a desired pH. You see, direct titration में क्या करते हैं हम लोग? Conical flask में metal ion solution we take. You add a buffer of pH buffer. And then I add an indicator. I will write metal ion indicator. Okay, metal or metallochromic indicator. And I will titrate it against EPP. Once you understand this, you can put it in your words. So direct titration. Metal ion solution is buffered at a desired pH. The desired pH. Indicator is added. and then it is titrated against EDTA. Simple. मेटल आयन ले लो, उसमें बफर डालो, पीएच एडजस्ट करो, इंडिकेटर डालो एंड टाइट्रेट. दैट इज डायरेक्ट टाइट्रेशन. One more thing is there. Sometimes auxiliary complexing agents like citrate or tartarate is added to prevent the precipitation, is added to prevent the precipitation precipitation of metal hydroxide. What does this line indicate is, see, sometimes what happens when you are adjusting pH about 10, pH about 10 होएगा ना, तो आप लोग anyways ऐड करोगे ना alkali. What happens then, sometimes the metal ion itself gets precipitated. अगर metal ion precipitate किया तो how will you estimate it? So to prevent the precipitation of metal hydroxide, you add tartarate or citrate. Please remember, in any time in your research, metal ions अगर precipitate हो रहा है फुकट, we don't want it to be precipitated. You can try adding citrate and tartarate. Whatever you learn in undergraduate, you will use the basic concept in your main research. Okay. So, this line is also very, very important. Auxiliary complexing agents such as citrate or tartarate is added to prevent the precipitation of metal hydroxide. So, if I ask you direct titration, it is simple. You will write metal ion solution is buffered at a desired pH, indicator is added and titrated against EDTA. Very important, auxiliary complexing agent is added to prevent the precipitation of metal hydroxide. Full 2.5 marks. Next. Next is your indirect or the back titration. So indirect, or I can write back titration. Now what happens is, मैंने इतना easy लिखा है, metal ion titrated against EDTA. It is not that easy. It doesn't become applicable in all the cases. So I will write, direct titration cannot be carried out. Direct titrations cannot be carried for any of the following reasons. Carried out for any of the following reasons. Reasons क्या है पहला? Metal ions may react slowly with EDTA. Metal ions may be very slow in reacting with EDTA. Or metal ions may get precipitated at the desired pH, or a suitable indicator is not allowed. Not available, not allowed, not available. In such case, what I will do is, I'll pipette out metal ion solution in the conical flask. I will add a known excess, known होएगा वो pipette से, excess of EDTA solution. I will shake. What will happen in conical flask? MyN minus 4 complex H ions will be liberated. ये conical flask में होएगा, and excess of unreacted EDTA I will titrate again. अभी मुझे बोलो, I will titrate. सी conical flask में मैंने metal ion लिया है, उसमें ज्यादा EDTA डाला है. जितना metal ion EDTA will react. Remaining EDTA I will titrate against a metal ion solution. This is important. The excess EDTA I will titrate against metal ion solutions such as zinc sulfate. EDTA एक्सेस टाइट्रेट करने के लिए ब्यूरेट में एसिड बेस नहीं चाहिए. ETTA हो गया तो ब्यूरेट में भी any metal ion commonly uses zinc sulfate or magnesium sulfate, zinc chloride or magnesium chloride solution. This is the back titration. The back titration पूछा तो first these three conditions you should write. When to go for back titration? When metal ions react slowly with EDTA, they may get precipitated or the indicator is not available. कोनिकल फ्लास्क में मेटल आयन लेने का, ज्यादा ईडीटी ऐड करो, शेक करो, एक्सेस ईडीटीए, यू रिएक्ट विद द मेटल आयन सॉल्यूशन. I think we should stop. Still two more type methods are used, which we will be discussing in our next lecture. Okay. Yes. Now